You have solved 2-sum. Probably wrong. 3 times in 3 years. 50 million submissions on LeetCode. The most attempted problem in history. Most of them solve it the slow way. Here is the problem. Given an array of integers and a target, return the indices of the 2 numbers that add up to the target. Array of 4 numbers. Target equals 9. 2 and 7 add up to 9. Return 0, 1. Second case. 3, 2, 4. Target 6. Notice, you cannot use the same index twice. Constraints matter. Up to 10,000 elements. Exactly 1 valid pair. Return indices, not the numbers. Walk into the interview. No editor, no compiler. What is the first thing your brain reaches for? Try every pair. 2 loops, done in 30 seconds. Easy. And that is the trap. Let me show you why. Brute force. Outer loop picks the first number. Inner loop scans for its complement. I sits on 2. J scans 7, 11, 15. 2 plus 7 equals 9. Hit. But what if the answer is the very last pair? You walked the entire matrix to find it. Time complexity? O of n squared. Space? Constant. Cheap on memory, murderous on time. At 10 elements, 50 operations. At 10,000, 50 million. At a million, 500 billion. Browser dies. It works, it passes the test, and it scales like garbage. You can do better. The trick, stop searching. Start remembering. Walk the array once. For each number, ask, has its complement already been seen? If yes, return immediately. If no, write this number down and move on. Look up, not search. That is the entire idea behind every fast solution. Now make it concrete. Approach 2. The 2-pass hash map. Build first, look up second. First pass, write every value into a map. Key is the number. Value is its index. After pass 1, every value has its index, ready to look up in O of 1. Second pass, for each number, check if its complement exists in the map, and isn't itself. I is 0, number is 2, need equals 7, map has 7 at index 1, return 0, 1. Time complexity? Linear? Space? Linear. You traded memory for speed. Worth it. But you walked the array twice. Build pass, look up pass. Both linear. Still O of n. Question. Can you do it in 1 pass? Yes. Check the map first. If complement is there, done. Otherwise, write yourself in. Move on. Here is the insight. To find the pair, you only need to look backward. Never forward. If the complement was already seen, you have the pair. If not, record yourself and continue. This is the version every interviewer wants to see. Code it now. The 1-pass hash map, the actual answer. Whole solution, 8 lines, read it carefully. Order matters, check the map first, insert second, otherwise you will match a number against itself. I equals 0. Number 2, need is 7. Map empty. Store 2, 0. I equals 1. Number 7. Need equals 2. Map has 2 at index 0. Return 0, 1. Done. 2 iterations, 1 pass, answer. Same big O as the 2-pass version, but half the constant and half the cognitive load. At 10,000 elements, 50 million operations becomes 10,000. 5,000 times faster. This is what O of n actually buys you. Not bragging rights. Real, observable speed. Edge cases. Negative numbers? Fine. Duplicates? Fine. That is why insert is second. Empty array? Will not happen. N is at least 2. Unsorted? Does not matter. The hash map does not care about order. But there is one more approach interviewers love to ask about, and it is a beautiful trap. Approach 4, 2-pointer, works only when the array is sorted. Sort the array. Pointer left at 0, pointer right at the end. Squeeze them inward based on the sum. Sorted array 2, 7, 11, 15. Left on 2, right on 15. Sum is 17. Too big. Move right inward. Sum 13. Still too big. R down to 1. Now 2 plus 7 equals 9. Return left and right. Time and login because of the sort. Space, constant, if you are allowed to mutate. That asterisk matters. But you sorted. The indices you return now point at the sorted array, not the original. ToSum asks for original indices. Fix, wrap each value with its original index before sorting. Now sort by value. Cost, extra memory. 2-pointer wins on ToSum 2, the sorted variant. On vanilla ToSum, it is the slow trap that looks clever. Now line all 4 up, side by side. The truth is brutal. Brute force, 2-pass map, 1-pass map, 2-pointer. Time, O of n squared, O of n, O of n, O of n log n.
Wait, this gets worse for one cloud you're not even thinking about.
Constant, linear, linear, constant, if you can mutate. Returns original indices. Yes, 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 not without extra work. Optimal answer for vanilla ToSum, 1-pass hash map. O of n time. O of n space, 8 lines. Done. Brute force, show you can write the naive solution first. 2-pointer, only if they pivot to ToSum 2. 2-pass, almost never. There is one trick that beats all 4. Sometimes. If the input is already a hash map of value to index, your answer is O of 1. Constant time. The problem disappears. Recap. Brute force, then 2-pass, then 1-pass, 2-pointer for the sorted variant only. Your default in any real interview, 1-pass hash map, state the trade-off, ship it. Pro tip, say the brute force out loud first, then optimize. Interviewers want to see the path, not the destination. And one question for you in the comments. When you saw ToSum the first time, what did you write? Brute force, hash map or 2-pointer? One word, content buffer.